For over 100 years, the Liverpool docks were essential to Britain's overseas trade. However, the new container ships of the 1970s became too big for the docks, and eventually they were closed. River quality continued to suffer as industry and population thrived along the banks of the River Mersey. Michael Heseltine famously said that the river was perhaps the single most deplorable feature of this critical part of England. After this statement, the government led a campaign to regenerate the Mersey River basin. It started with the Meepass Tunnel, which connected 26 outfall pipes that were discharging effluent straight into the Mersey. It was linked to a new treatment works in 1991, which could accept 11,000 litres of wastewater a second. Helping make real improvements to water quality, it has served over 1 million people.
It was full of sewage. Added to that was all the industrial waste, well, there were balls of fat. Mix all that up with all these other things and you had liquid coal effectively.
It was dirty, it was foul smelling, you'd have floating rafts of sludge. It wasn't pleasant to be alongside.
We are continuing to invest in Liverpool's sewage treatment works so it functions better for future generations. So how do we make our ability to treat wastewater more robust? We're building a brand new state-of-the-art secondary treatment works. The new works is being built in Wellington Dock, next to the existing site. When completed in 2016, it will meet customer demand for many years to come. Wellington Dock is in a World Heritage Site buffer zone, and the construction team had to deal with preserving and incorporating dock heritage in case it needed to be returned into a working dock in the future. Layers of polluted silt and marine life had to be removed from the dock. Checks for unexploded wartime bombs also had to be undertaken. After confirming that the dock was bomb-free, the team relocated the marine life back into the Mersey so the cleaning process could begin. To keep the tidal water from the Mersey out, a closure wall was built. The dock gates were then closed for the first time since 1946. Over several weeks, 206,000 cubic metres of sand were poured into the now watertight dock, and the water pumped out. 850 concrete piles were then drilled into the sand to stabilise the foundations of the site. Our skilled workforce of up to 350 people has allowed us to overcome several technical challenges. One major design challenge was that this site is situated on about 40% of the space that a site of this water capacity is normally built on. The team's only choice was to build upwards instead of outwards. On a normal activated sludge plant, wastewater has to go through an aeration tank before going into a final settlement tank. A sequencing batch reactor, SBR for short, does all of these processes in sequence in one tank. The SBR uses microorganisms to remove harmful bacteria, leaving the safer solids to clump together. Special aerators at the bottom of the basin add air to the water, allowing the microorganisms to thrive. It then acts as a settlement tank, where solids settle at the bottom of the basin, leaving a top layer of clean water, which flows to the river via the outfall. There are 16 basins in the new secondary treatment works spread over 2 levels. Building on 2 separate levels proved to be another design challenge, and the team had to use techniques to build scaffolding and beams to the appropriate height, allowing concrete to be poured to create the second floor. The new site will also have a brand new sludge treatment plant. This plant will thicken the sludge in order to best extract methane, which in turn provides heat and electricity to help run the site using the existing combined heat and power assets. Through the team managing the build and innovative use of the latest technology, all of the design work has been done in a digital and virtual world. The level of accuracy has allowed us to construct much of the scheme off-site in a modular form, transporting fabricated items to the site for installation in a coordinated build sequence. The technology extends onto the worksite as it is built, allowing engineers to view where cables or mechanical features need to be installed. Once the scheme is complete, the information will go forward to support the operation and maintenance of the works throughout its asset life. Extensive refurbishments and updates to the existing treatment works are being made to ensure the site is ready for the new secondary works to come online and to meet EU regulations. The primary settlement and storm tanks have been refurbished, and updates will help with odour control and improved environmental factors. Each of the 8 pumps at the inlet works are being replaced. This will help maintain the site's current wastewater intake of up to 11,000 litres per second. Throughout the project, the construction team is ensuring that the existing site is kept 100% operational whilst the work is being done. Each update has to be planned precisely, as sometimes we have to turn off the whole works whilst essential tasks are undertaken. Each planned outage can take around 4 to 6 hours, and during this time, wastewater is temporarily held back in the MIPAS pipe. All of this delivers environmental benefits and happens without affecting our customers in the Merseyside area.
We're members of Pool of Life, which was the UK's first breast cancer survivors dragon boat team. We had them all over the world, but not in the UK. And we were formed in 2004. Well, initially, after treatment, you have low immunity anyway, or if there's any cuts or anything, if you've got any waterborne germs, that there would be a major issue. But it was something when I joined in 2004 that I never gave a second thought to be perfectly honest, because the water was so clean.
So, how do we get the cleaned effluent into the river? Although this water is clean, it dilutes the seawater in the immediate area as it hugs the banks of the Mersey, and the imbalance in water salinity has an effect on local marine life. The solution was a new outfall extension pipe, which is 285 metres long, terminating with 3 diffusers to aid dispersion. The current dilution effect will be improved, enabling marine life to thrive in more natural conditions. The outfall pipe was built in Norway. It was then shipped to Liverpool, where it was prepared, whilst a trench was dug in which to lay the pipe. In August 2013, the pipe was dropped onto the seabed and connected to the plant.
The fact that we now have salmon returning, I couldn't believe that that was going to take place in my working lifetime, when I think back to 1970 when I first started regulating the river. I think the river is a key indicator. The environment's improving generally. We have cleaner air, we have cleaner land, and of course we have cleaner rivers.
The programme of works will complete the second largest treatment works for United Utilities and will maintain those improvements we've seen happen over the years in the Mersey estuary. Since the introduction of the treatment works, the Mersey has changed from a heavily polluted river to one where salmon and even grey seals can thrive. We're committed to playing our part and keeping those improvements going, ensuring a cleaner river for everyone, young and old. This is the future of keeping the Mersey clean.